Assalamu alaikum, dear students. We're back with another video lesson. In the previous video lesson, we were talking about the coefficient of self-inductance, or L, you could say. Gutman, coefficient of self-inductance, it is the ratio of the magnetic flux that crosses a circuit to the current that traverses the same circuit, or traverses it, right? And then we said the coefficient of self-inductance for a solenoid is equal to mu naught times n squared times the cross-sectional area divided by the length of the solenoid. We also said that of course, it's possible that they could ask for the coefficient of self-inductance for a coil. In that case, everything would be the same except that the denominator would be would equal to 2r. Basha, yani the equation كده بيتا mu naught times n squared times cross-sectional area divided by 2r for a coil. Basha. Today, and then we stopped right at this point here. By the way, these are some of the units, let's say, and their equivalents that we have so far, Basha. But these are not everything, but of course you can say most of it, Basha. So for example, you could say, what is Henry? We know that. What is Henry? What is Henry is obviously the SI unit for coefficient of self-inductance, you can say, which is also, you can see that it is equivalent to each one of these units in here. For example, let's say, and what I have done here, I've wrote, for example, like where does these units come from? For example, coefficient of self-induction or Henry here, it is equal to what? It is equal to the EMF times the delta T divided by the current, later the volt times second over ampere. But we know that volt over ampere, this equals to ohm here. So in this case, of course, it becomes ohm times second. Current dakata yan bablin EMF lesser current dakata say dakata resistance, and the unit of resistance it is ohm here. We also have, for example, if you go back to this equation, Gutman n times flux dakata I times L, agar lira Gutman L ke wagri dakata n times flux lesser I n ke unitinia. It is a number of terms you can say. Basha. So for the flux or the unit of magnetic flux, it is Weber, and the unit of current, it is ampere. And you can see that with all the other units here that you can see, Basha Baba, these are something very, very important. I'm sure that if you practice them, it will help you a lot. Basha. Now, for example, like we have two questions here. These are bin and Wizad. It says, which of the following is equal to Henry? Bash Baba. One of the things that we have, ohm times second squared what about this one here? This one cannot be as well. Ohm second one here. You can always go back to the main equation, Baba. ليرة فولت أمبير دكاتة أومز أوم تايم سكند أو دبيته ولا مراسك أو إيش غلط دبي لو حالتي باشا كاتا which of the following is correct. Later it is regarding the Tesla, which is the unit of magnetic field strength بابا أما عادة 8 فولت أجر أو equation ما هي بابا قلت مان EMF دكاتة negative n بابلن changing. Let's just do this one. Changing magnetic flux, which is equal to AB cosine divided by delta T. Subject, which is in the B dakata tselera yang changing B dakata EMF times delta T. EMF times delta T. لسات شيء بابا لسات that one imply negative n أو negative كبيني سرش مشكلة إنها times the area. Later the beta EMF it is measured in volt time second. Number of turn has no unit area because the beta meter squared. This is one of the units that we have that is equivalent to Tesla or B here. Basha. Later it's money baba later 20 blade second duzamani kata second duzania. Basha. Later Tesla baba in volt second less meter squared. That would be correct. Later liberoi meter baba in our unity area ini agali baba this meter. Kata this incorrect, and this one also incorrect. Kata the only correct answer is going to be option B, Basha. And of course, if you use this, Basha, this table or this diagram, this chart here, flow chart, it might help a lot, Kaka, or whatever, maybe chart, whatever that you like to call that, Basha. It might be very, very useful. So, Yanish Baba, Zodi unit Takan, some of the units are very detailed, and it goes several steps. You don't have to go several steps. Just know the main equation, Baba. What's the main equation? Okay, go one step further. For example, what if you change or rearrange? Okay, you can get different units, and of course, that would be great. Basha. بسارش دي كمان here says if the number of turns of a coil is doubled by winding another layer of turns above the original one and it is in the same direction. Basha, what happened to the coefficient of self-induction, Baba? Later, self-induction وجماري كلش معنى باشا بابا. So whether if it is a coil or solenoid, my coefficient of self-induction دكات بابا دكات mu naught n squared times the area divided by 2r. قريبا if this is for a coil when I get solenoid وبعد ما نقول L باش كاكا. But here for example for coil since the question is about the number of turns, whether for coil or solenoid doesn't matter. What is the relation between coefficient of self-inductance لقينا كي بابا? Because the number of turn is squared كاتا coefficient of self-inductance it is increasing يعني زاد دكاتن by 4 times باشا and the multiplied by a factor of 4 doesn't change anything. Because of this too كاتا L is so the number of turn is doubled. So جمارة كي بابا هرتسن زارك بوا you just write that for example and make sure that you square it and then whatever the answer is that is going to be the answer for that. And of course now what if they change for example the area, what if they change the radius? I got maybe it is inversely proportional with the radius. I got solenoid بوكاتي the beta L it is inversely proportional with L. I got لو خالنا بهم زاد بابلن equation كي بنوسا see the relation and then you could do the math just to see which one it is here. Basha, regarding the coefficient of let's say self-induction for solenoid baba, we have this very important question baba. The reason why it is very important because it's kind of like you have to do like at least 2 steps in order to get to the answer here. So let's see how we could solve this question together. Basha, first of all, we have to see what is given and what are they asking for here. If you want to do a question very well, then of course that gives you a clear clue what do you need to find. So it says an air solenoid. So clearly we have a solenoid of length 10 centimeters. So this is the length, Basha. Length come on 10 centimeter. You can convert that to meter. That'll be 0.1 meter. That is the length. Sidi Kashmane, cross-sectional area. I got data baba. Cross-sectional area it is in centimeter squared. How do you convert centimeter to meter squared, Baba? Because it is 25 centimeters squared. عاد نقدر بتا centimeter squared بكيمتر squared بابا ده بيتا 10 ده بيتا meter or you could just say 25 أو كاتي centimeter كده بيتا 10 بابا ده بيتا 10 to the power -4 meter squared. Let's say because baba centimeter there are 2 methods you could do this one here. Each centimeter is 10 to the power -2 when you liberate centimeter square. Now you just square this one here. So -2 squared, that is going to be what? That is going to be, or you just multiply this one, you get -4. That is one method. When method شديك بابا centimeter times centimeter هناك كاتا centimeter squared. We convert كبيمة the beta 10 to the power -2 or 10 to the power -2 كواتا استا او the beta ماتر or the beta ماتر كواتا the beta تسبابا 10 to the power وزبالي بنوسين 10 to the power -4 meter. بس تبيرست square شو طبعا. You don't have or you don't need any of these بابا. هر كاتك centimeter squared بو بتبي كمتر باشا سكوير أو كاتي تنها زاراني 10 to the power -4 أو كاتي that would be or you would be converting centimeter squared to meter squared. باشا سيدي كشمانة جمارة turn كان بابا number of turn is 400 turns باشا سيدي كشمانة the is traversed by a current بابا currentك مانه currentك تسنده it is 4.0 ampere. بسارك the first part of the question says calculate the magnetic flux which crosses the solenoid. I got لي بابا the magnetic flux now let's change in flux. رنقل لي ما وصل فرق يدوش تيسير. بابا كده let's change بابا magnetic flux أوقاتي you only have one equation to do at this point right here. So let's erase this one. كده magnetic flux I got لي we only have one question that we have this and it was this. Good man. N flux باشا it is equal to what? It is equal to L coefficient of self-induction times the current. ليه بسارك تسيدي بابا flux there, and that is the equation. So get change in flux button. Okay, you might need, or perhaps you might need to use Faraday's law of electromagnetic induction, which is equal to change in flux over delta T. And yeah, that is one of the differences here. But liberate change Kenya, you can use this equation, which is for the self-inductance here. Self-induction. زور باش اللي رتمان دي باب سارك ضل calculate the magnetic flux زور باش كاتا magnetic flux that كاتا say according to this equation it is equal to L which is coefficient of self-inductance times the current divided by the number of turns in here. إذا current كمان هي جمارة turn كمان هي بس coefficient is self-induction mania. Can you find the coefficient of self-induction? Well, you have to, Basha. Now, how do you find coefficient of self-induction, Baba? بس قال لي ويشتش دي كش مانية ليرة coefficient of self-induction لو شيء لو solenoid. We've already learned about coefficient of self-induction for solenoid. تبارنج كيف قرن coefficient of self-induction for solenoid equation كتسو Baba. يلا دي بيمان بلاي equation كقط مان دكاتة mu naught Basha times n squared times it's about times an 11 area divided by the length of the solenoid here. Basha. زود Basha. Esta mu naught 4 pi times 10 to the power negative 7 times جمارة ترنكان it is 400 I got ليبي square Basha 400 times cross sectional area كقط مان 25 times. Let's make sure we have enough space to write this. Basha. Man 25. Was it 25? Yes, 25 times 10 to the power negative what? Negative 4. Good man, a meter square. Basha. And then divided by the length of a solenoid, which is 10 centimeter. You convert that to meter, that would be 0.1 Basha. So now you can find the coefficient of self-inductance. Basha. Coefficient كده كانت سنبابليرة. قلت ما شاهدش كني. Coefficient كده كانت 5 times 3. Basha. عفوا 5 times 10 to the power 5 times 10 to the power negative 3 Henry. Basha, this is the coefficient of self-induction. Is that since you found this one, you can bring this, of course, into this equation right here. Oh, Drawanish, Zor Basha. So now all you have to do is just bring this number right into this. Okay, so once again, flux and magnetic flux takata tsbaba. Magnetic flux Gutman L, which is 5 times 10 to the power negative 3, right, times the current that we have, current to command 4 ampere, divided by the number of turn, which is 400. Now do the math, of course, you'll find the answer, which is equal to 5 times 10 to the power negative 5. Basha, flux kata 5 times 10 to the power negative 5, so that you can write Weber if you want to, since it is a magnetic flux. Yani the 20 belay. It is Tesla meter squared, because these two things are exactly the same thing, Basha. So you could choose one of them, obviously, but this is the SI unit. Weber would be the SI unit. Let's just keep Weber, which is the SI unit for magnetic flux. That is the first part of a question. I gotta leave out. What is the second part of a question here? The second part says, all right, so remember these are what we have so far. The second part says, if the current is reversed during 0.1 second, calculate the induced EMF. Basha, what does this mean? The current is reversed in 0.1 second. It was 4 ampere, which was positive. If the current that we have, for example, let's say it is 4 ampere and it is positive. If the direction is reversed, what does it mean, Baba? Direction could reverse. If this is to the right, to left, that is going to be negative, right? So we can say current 2, it is going to be negative 4 ampere, because it is the same amount, by the way, the same magnitude, it is just reversed. And direction reverse بويتو يعني عكس بويتو amount كنقول أقل لي بتنها current بعدين direction current كيقول in a time which is equal to 0.1 second. ماشي؟ بشارك دلة سببينا بشارك دلة calculate the induced EMF. باشا سببينا بابا أو EMF كا induced با زور باشا استاكا. Now, what equation do you think we're supposed to use now, Baba? لبري current كقول coefficient self-induction إيش مانديته ولا Babylon do bashay sare. You can easily find this one now. When you kata dalan EMF dakata sababa dakata negative L basha change in current divided by the time. Basha, you might say, how do I know which equation do I need to use? For example, skip saraka dalay EMF akibabino when you rangabale EMF dakata basha using Faraday's law dakata negative n change in flux over delta t when you because this is using Faraday's law equation it has a self-induction the kata negative L change in current over delta t baba har kata current kagora you'll have to use the equation of self-induction agar changing current tabu basha agar current kagora over time of course awkati you'll use the equation of self-induction but agar magnetic flux kagora for example like be a magnetic field like a gora. For example, if it is inserted into a magnetic field. یا لەناو ماگنتیک فیلدەکەی دەرهێنرە ئەو کاتی دەتوانین بڵێ ماگنتیک فیلدەکە گۆڕە دەکرێت ئێریایەکە بگۆڕێ ئەو کاتی you'll use fired as law چون magnetic induction بەس لێرە مادام کرنتەکە گۆڕە so we'll use this equation باشە کاتە دووبارە دەڵێن EMF دەکاتە negative L-ەکەمان چەند بوو بابە I think it was what was it 5 and 3 it was 3 times wasn't it 3 times 10 to the power negative 3 let's double check this one again باشا عفوا 5 times actually 5 times 10 to the power negative 3 that's ما نسي لا بيشتري okay I felt like I wrote 3 يلا دي 5 times 10 to the power negative 3 good man times this that كرنت كجورا بابا كدلين delta I أو كاتي دبيت تسي delta I دبيت I2 minus I1 yeah this is what it is so now I2 here what is I2 بابا دلين كرنت كا جورا reverse بو so is that كرنتي دوم دبيت negative 4 minus أو minus equation كي بابا أو شيء direction كي كرنتي كمشي was 4 ampere yeah divided by the time come on good man sambu it is 0.1 second is that negative 4 دبيت negative 8 over 0.8 over 0.1 باشا دبيت تسن بابا دبيت negative 80 you can multiply this negative وكاتي negative 80 with this one دبيت positive EMF كا آخري بكالكوليتر حسابي كا دبكاتا 0.4 volt بابا باشا this is we can say that the induced EMF when the current changes by that much I hope it is clear enough is that if I summarize this one baba what exactly did we do yani بعد summarize كان كان زب سارك قلت flux كي ببينا we use this equation قلت man n عفوا we use this equation قلت man L times I over n ونيا L مان نبو E solenoid من مكان هنا L كمان ديتو دواء flux كمان ديتو بس يدومش دلاء EMF كي ببينا EMF كا دكاتة سبابة دكاتة L because the current كجورا we'll use this one change in current over time باشا ليش current عادة دبيت I2 minus I1 باشا بس I2 كدلت إنها direction جورا كاتا I2 كدبيت negative 4 I1 كاش positive 4 you do the math of course you can find the EMF وابزام هذا وندي بسارة شيء جوانا أجر اللي خد practice كان إن شاء الله هذه مشكلة اللي قلنا أبي أكيد أبزام تا وازعيشة أو بسارة كان ديك بابا ويكو هيت ما نستر موزاي تنها جمارة لتزيدانا نوي تسيدي كش ما نباشا for example like this question here says the electric current grows in a circuit باشا from 0 ampere to 10 ampere كاتا this is I1 and this is I2 yeah during on that if the coefficient of self-induction باشا تسنده it is 0.02 Henry أو كيا بسالك ضل calculate the induced EMF إتنها equation كي بكاربين قلت من ضل negative delta I over delta T ونيا يلا دي delta I دبيت I2 minus I1 هاي كان لسه delta T كي ونيا ستنها جمارة كان لزيد أبنيو والله ما كي ببينا which is supposed to equal to negative 2 volt باش بسارش دي كمان ضل which one leads to a higher increase in the coefficient of self-induction of a solenoid أقعد زولو بسارة نبي ضل doubling the number of turns باشا of its turns or doubling its cross-sectional area كان لو أنا effectكي جورتري بابا so each coefficient self-induction solenoid equation كله خد نسقط من mu naught n squared times a divided by the length ونيا أو solenoid كاكا زور باشا است تسمعني بابا ضل doubling the number of turn or cross-sectional area قلت ما شاء جماري أويك بابا وسكوير ونيا طبعا نقدر جمارك سكوير بي effectكي جورتر دبي لو يكابا بسكوير كاتا doubling the number of turn would have a larger effect تنكا سكوير زور باشا أولش والله ما كله يدعي بقى عندك برسالي وزاري ما نهي ليرا قدر با يقدو برسال له حالكم the creation of an induced EMF باشا in a circuit due to the variation of its own current بابا أو keyword هل كاتا قوتي own current يعني دبيت self induction أقال لبي own current يعني because يعني بابلين resulty like it is a result of changing its own current هر كاتقول own current يعني it is inside itself this is what we call a self induction باشا أو self induction قلت مان هنري دكاتة سبابة هنري دكاتة units or one of the unit was قلت مان second بوني أقل بيت بوبي كاتا متر مانية وبر متر دوزا من هي ليرة باشا وبر متر دوزا لشياتي بابا تواني بلي أجر تسبتنا أجر ليرة رات مشاكل بابا يعني وبر over ampere أو أنا مادام هنري وويبر شي دايني بابا كاتا هنري فلكس او equation معنا بو بيكو قطمان n flux دكاتا l times current ونيا وتزليرا باسي هنري دكا بابا l كيبكا subject دكاتا n flux لسر current ونيا انا كيونتي ني هر لايبا مادام يعني جماري تيرنا كان باشا زور باش كاتا e flux over ampere flux كا ويبرا امبير كش كريم نقل لسر امبير كاك لسر امبير كاتا دبي والله مكا يعني بابلين تكا ويبر بيتن what kind of Weber is this ويبر لسر شيء لسر امبير بابا بي هذا ويبر متر دوزا وما نية كاتا ويبر لسر امبير والله ما راستك يا عشان نيوتن متر غلط بابا زور باش سيدي كشمانه برسالي دي كشمان زورة طبعا اوانا او قتمان او يونتاني سري بكار بينا بابا والله ما كان دبيني ابزام زور اسانه. One of the following is measured by Henry ابزام وجه اسانه coefficient of self-induction ونيا طبعا we have another thing later we're going to study which is called coefficient of self after mutual induction which is going to be studied later. دير تسمعني بابا قال لب سارج بيدلي when a circuit through which a coil is connected the switch is off باشا the self-induced current باشا current in the coil is on. Percentage page one about. That's when a circuit through which a coil is connected. ما circuitك معناها لقى coil شي باشا. This coil is connected. It's a when the switch is off. يلا كاكا you tell us for example like switch okay off كي بابا يعني استاك heat current دي كبناو نارو. Let's say this is a small circuit just something like this باشا. استاك circuit كيو like previously when there's a current when the switch is closed. Obviously, there is a magnetic field around the coil, and I believe you agree with me. When a current is flowing through a circuit, there is a magnetic field around the coil. Let's take the current stops flowing through the circuit. What I'm talking about, it happens during in a fraction of a second. But just think, like imagine you see this in slow motion. Open magnetic field sabr kam daka so we could erase this but my magnetic field sabr kam daka because the current is decreasing so when the magnetic field around the coil is changing can we say there is a change in flux first of all current because now there's no more current is slowly decreasing through the circuit because the switch is open or you can say it is stopping or fading away. Okay, when the current is changing at man flux there is also a change in flux. باشا او change in flux ودا كاتن تدرس بابا EMF كو current درس بيتن EMF لقى current او ما استاذات الباستك كان باسي current او current induce its own magnetic field ونيا قلت man او magnetic field that is induced will oppose the change in the magnetic field of the coil now بابا باشا magnetic field that is decreasing. How does this induced EMF oppose that, Basha? It's like a magnetic field that decrease ka baba. Away ka induce the like tries how the car ka Basha? How does it tries to prevent it when by being the same direction and opposite direction kaka. So how do you try to keep the total the same as much as possible by being the same direction and opposite direction? أو أي بابلين إيستر كتكيا أو كرنتي كاندوز بابا in this case it's about this decreasing magnetic field like decrease the كاكات أو كرنتي كات decreased induced بابا it is going to be in the same direction as the current that is in the coil to keep the total the same to prevent it baba from decreasing furthermore باشا كات لو حالة دلان أو current in the coil it is in opposite direction of the main current نخير تسكير opposite بهشتن زيادة كم دكا كاتا it does not keep the total the same B delay is in the same direction of the main current the same بيتن حتى total okay but constantly بهاليتو for as long as much as possible باشا كتمان zero ناكري none of the above none of them وش ناكري أقعد لو بسارة بي بسارة شي باشا سيدي كش معنا وانا ابزام اسانا بسارنا تنها لزيداني وخلاص برا. Coefficient of self-induction of a solenoid is directly proportional to which one of these بابا؟ هركاتا قلتي if you're not sure write the equation coefficient of self-induction for a solenoid ابزام we said it enough times mu naught n squared times a divided by the length they're directly proportional like a بابا like الهرهم اوانا mu man هي بابا mu naught doesn't matter here area man هي n squared man هي كاتا all of them at this point right here دو پرسیاری دیکەش لێرانە مان the coefficient of self-induction is inversely proportional لەگە چی بابە it is only with the length باشە هەر equationەکەی تازە نووسیمان بابە بینوسەوە جارە inverse لەگە چیە ئەم زەمە پرسیارانش بەشە چی باشی دووبارێ ئەوانش ژمارەکان لە جێدانەوە you'll find the answer زۆر باش ئێستا کۆنسەپتێکی نوێمان هەیە بابە is called eddy current باشە what is eddy current eddy current هەر لە ناوەکە ڕادیارە بابە eddy it means circular current باشە so what is exactly circular current we'll say that when eddy current it is a circular induced current baba within we can say a conducting material how exactly does this happen kata it is we can say the induced yan the twain blend eddy current that is a current that is induced basha yan circular current that is induced within the conducting material how does this like how does it happen when a conductor it is moved into a magnetic field kata conductor the magnetic field that baba أو جماري a magnetic field داني for example passing and bubbling acting at right angle especially if it is right angle though باشا جماري magnetic field that are cutting the conductor will change when you cut the twine blend flux كجورا and as a result of this baba EMF and the twine blend current لنا conductor will be رود ده يعني bubbling will be induced باشا once we move the for example conductor into a magnetic field baba because now more magnetic field lines are being cut as that there is a change in flux as a result of that a current will be induced inside the conductor that we just brought into the magnetic field but for example this current that is induced inside the conductor it is a circular shape we can say or pattern basha that circular current here is what is called eddy current باشكاكا أقل لو خاليبي so for example لو example تشديك هروكو diagram لو إزاتة تبقى بابا as we أو زدكري magnetic field أكيد نزيك conductor كيكوي and vice versa it doesn't matter for example at this point once we bring this magnetic field close to this conductor here you can see that as the magnetic field lines are cutting through the conductor you can see that circular currents are induced inside the conductor this circular current it is what is called eddy current وطبعا دواء بابا قلت من هالكاتا كرنتك flow كاتا magnetic field that induce the كاونيا كاتا now this circular current it would induce its own magnetic field this own magnetic field there it is opposing with the magnetic field of the coil and as a result of this opposition you can say this conductor heats up باشا so precitic money later the twine blend the kinetic energy due to the motion of the conducting material inside so like most of the time we move the conductor into bubbling into a magnetic field this movement here baba yan this energy of movement which is kinetic energy will be converted into heat energy so the conductor as a result will heat up basha sometimes if this would by the way like you don't have to move the conductor into a magnetic field or inside the magnetic field I get magnetic field it is changing already basha the krila way like instead of moving the conductor or the what is it called the coil baba and the magnetic field the kriya AC bakar bini direction magnetic field it automatically reverses what it gives you the same effect as if you for example move the conductor inside a magnetic field as long as the field is changing when that heats up the material even if it is not moved inside the magnetic field as long as it is inside the field basha is that the next thing or the next point that we have that is something very important like I can tell you that it's been in Wizari several times basha the question is what are the applications of eddy current بكارنا أنا كان application كاني eddy current and تشتق بكار دي بابا سي application man here these are super important أقال لي بيا كمان in furnaces هان قلت معنا مسموني حذري man here سموني automatically man here باشا so for example you just put let's say the DAW in and then you will wait let's say a few minutes and then it just you can take it out and of course that will be turning the dough into bread basha yeah and it could be in bakery you could say that too basha in car braking system basha especially those we can say those that are hybrid that could convert the motion into electrical energy you can say but that's not important basha tanha bakarina gamzana in furnaces in car braking system also in detecting metals in airports and underground basha these are the uses of eddy current there are a lot of uses for eddy current بابا لو أنا تنها عندك example رسم له ما أنت تنها له وكو تيجيشني زيادة لكن أشتا تشيوانيا أقال لي بابا eddy current زو قرنجا احتمالي هات نوي هي which of the following is not? So these are most of the time questions will be like this. Says which of the following is not one of the eddy currents application? Basha. In furnaces bakarde. Basha. In detecting metals in airport and underground wash application. There's in car braking system, that is another application. In the construction of spectrometer, Baba, is not one of the applications. The eddy current is used in what? In furnaces, in detecting metal ground, car braking system, and all of them. And can be used, but not which one of the following is not used here. Furnaces, Gutman, car braking system, detecting metals, measuring distance. It cannot be used in measuring distance. This is not one of the eddy currents application. A circular current is a section review بابا. A circular current loop made of a flexible wire is located in a magnetic field. Describe 3 ways that an EMF can be induced. Basha. There are 4 ways we can induce EMF. One of the way was by moving the circuit in or out of a magnetic field. The second way was rotating the circuit and the coil inside a magnetic field. Third method was by increasing or decreasing the intensity of a magnetic field line, yani reverse direction كامل. Which we said that's less efficient by changing the cross-sectional area. So we could count the first 3 because these are the most effective ones here. And this is the answer. A bar magnet is positioned. Hopefully you understood, like how we can solve questions like this from the previous question that we solved in the other session or lesson. Question you do on Baba, let's say a bar magnet is positioned near a coil of wire shown here. What is the direction of the current in the resistor when the magnet is moved to the left as in A and then moved to the right as in B? So for example, that is if a magnet is moved away. If the 2 are approaching, the magnet and the coil, here's a magnet, Basha. If it is approaching, they will have the same pole. Then how what was that? If it is approaching, they will have the same pole. If it is moving away, the opposite. Let's apply this to what we have. So this magnet is moving away. That moving away is going to be opposite pole. Like a north, the south. Very good. South, north. Align your hand or your right hand as this. Your thumb must be pointing north. Your 4 fingers are pointing downward. Direction downward. Follow the direction of the current here. If you follow this one now, you can see that the current is flowing from where to where, Kaka? From this side is left, right, we can say from left to right on the resistor. That's the simple yani. There's nothing more than that. That is for part A, Bash Kaka. Now what about for part B here? For part B, as you can see that it says if the magnet is moved, let's just hide this one here. You can see that for part B now, the magnet is moving towards the coil. If it is moving towards and the same direction, if it is moving towards, Polakan would be the same direction. Same baba. North beaten. North beaten north like south. Now use your right hand rule. The direction is upward this time. Now just follow the line or the arrow here. It is going from right side to left side. So this will be the direction of the current on the resistor if the magnet is getting closer to the coil. These are section review, by the way. This is the same as the previous one here. But I would like, I would like you to focus on one thing, for example. What equation do I need to use here? Magnetic field use Faraday's law of electromagnetic induction. Use coefficient of self-induction equation. Bubble self-induction equation is self-induction. Says 256 turn. Let's make it quick. This is number of turn here. Basha coil with a cross-sectional area kishmani, it is in meters squared, you don't have to convert. Place a uniform external magnetic field of strength on the kata magnetic field kmani on there. Says so that the plane of the coil is perpendicular to the field. Awkati goshaka sifra. Basha. Gutman, the coil is pulled out steadily. Kadala pulled out steadily, yani B2 mansan nababa B2 the beta 0. Kata satsagora magnetic field kagora. And this is delta time. Pisara kadala find the average induced EMF. Gutman is that current nagora when current aslan hatedani. And then, of course, because of the magnetic field is changed, kata EMF the kata negative n a cosine theta, we can say B2 minus B1 divided by delta t. Negative 256 times area, come on, 0.0025 times cosine 0 times B2 says pulled out, kata B2 is 0, minus B1 was 0.25 Tesla divided by the time, which is 0.25 second. You do the math, of course, you'll find the answer. Negative beta positive akhiri. والله ما كده كانت تصل كانت 0.21 volt. And that's it. والسلام. زور باش. بسارش دي كمان هي ضلت سبابة. That is this question here. All right. بسارة كده critical thinking. Electrical guitar strings are made of ferromagnetic material. باشا ferromagnetic material سبابة. أو مادة كازور باساني دبنا مغناطيس وزور باسانيش. Magnetized yan bablan sifati magnetized when the can once there's no magnet around. Basha says that can be magnetized. The string lie closely over and perpendicular to a coil of wire. You can see that these are perpendicular to a coil of wire. You can see that. And of course, there's a permanent magnet there as well. It's a permanent, it says inside the coil, there are permanent magnets, as you can see here, that magnetize the segment of the string overhead. So once this string is, let's say, vibrating, or clearly that this string is magnetized, you could see that, you can say, because of this permanent magnet now. Now, as the, so let's just keep reading the question. It says, using this arrangement, explain how the vibration of a plucked string produce an electrical signal at the same frequency as the vibration of the string here above. So then, for example, once you plug the string vibrates. When a vibration of string of course, will be converted to electrical signal. As our electrical signal would be taken to an amplifier and then to a speaker. As that once the speaker changed that signal back to a sound, frequency of sound they come. It is exactly the same as the frequency of the string that is vibrating. The string that is just plucked. Basha, string you just, for example, plucked. So how does it exactly happen? Because of this permanent magnet, is the string it is also a magnet, as you can see here, Basha. So that is what it is. As that once you plug the string baba, it's the magnetic field of string. Of course, it is going to yan babbling because it is vibrating here over this coil. You can see that. But man flux and magnetic field line as a result of that, the change of these magnetic field lines on this coil here, that induces what? Induces an EMF. When the string is plucked, Basha. So that, of course, changes the flux, Basha, and magnetic flux. A magnetic flux ababa that one blend to the zakatan, EMF current we can say that, Basha. Current but current, of course, this current, you can see that, or you can say because of this string is going back and forth, frequency here, we can say that. So the frequency of this current that is induced, it is going to be something like this. Let's assume that it has AC alternating one, So you can say, Baba, you can think of it this way, Baba, no string here. When it goes sideways, Baba, or it vibrates, Baba, when it goes to the right, it might, for example, the direction magnetic field. What about when it's vibrating left? Imagine this pen is the string here. Once it's plugged, it vibrates back and forth, for example, or it could be sideways. Doesn't matter. Like it doesn't matter. It could be up and like this way or sideways. Sideways would be best. So let's just consider using up and down here. Once it is going up, that is a sort of electrical current with a single or a certain property. You can call that positive. Once it is going down here, because now it's the direction magnetic field reverse the baba, you can call that yan bubbling direction current reverse. In that case, you get negative bubbling negative electrical current. As a result of this, you can have a varying electrical signal بابا يعني بابا أو signal the beta AC, which stands for positive and negative. That is, or this current يعني بابا frequency أو current generate بابا, it is exactly the same as the frequency of this string that is vibrating باشا. And you know that frequency vibration you can say when so in this case, of course, once this signal goes to the speaker, you get exactly the same sound as the bubbling frequency of bubbling. You get the same frequency with the bubbling. You get the same sound, bubbling the sound with the same frequency as the frequency of this vibrating string. I hope you got it, Basha. This is how it works. So you can see that when the electrical guitar string vibrates over the coil, it changes the magnetic field around the coil. This changing of a magnetic field, you can say flux, induces an electrical signal in the coil, Basha, through electromagnetic induction. Process of induction. The frequency of this induced electrical signal, Gutman, matches. It is exactly the same as the frequency of the string's vibration, allowing the electrical signal to represent the sound of the vibrating string. Rasha? And that's it. بسارش ماني بابا حالو كل خد حالك بسارش يا سانا بزام تنها لزيد أنا نويا, and you can find the answer. زور باش. وابزانم اون دلو سيشني بس بيت إن شاء الله. Next session we're going to start with electrical generators. Basha? So till then, keep practicing and I'll see you soon inshallah. Assalamu alaikum wa rahmatullah.